So write the first 6 terms. Oh wait, let me have you add something here. Just for a reminder, a sub n minus 1 is a symbol referring to the previous term. N refers to a term's position. Just as a reminder. All right, so here, let's look and see what we have. It says, write the first 6 terms of the sequence. They gave us a sub 1. And then this is the function that we're working here. A sub n equals a sub n minus 1 plus 3. This says, take the previous term's value and plug it in. So we have a sub 1 already. So now we're going to find a sub 2. So I'm going to write a sub 2 is equal to the value of the previous term, which is what? Negative 2, right? The value of the previous term, which is negative 2, plus 3. So a sub 2 would be equal to what? 1. Then I'll do a sub 3. This is equal to the value of the previous term, which is what? What's the value of a sub 2? 1. So that's what I'm going to use here. And that equals what? Okay. So now we have the first 3. 1, 2, 3. And we need to do 2 more because we need the first... Oh, no, we need to do 3 more. We need the first 6 terms. So a sub 4 is going to equal to what? The previous value, which is what? 4 plus 3, which equals 7. A sub 5, you get the hint now, I think. Right? You see in this pattern? And a sub 6 is equal to 10 plus 3 equals 13. Make sense? Okay. All right, let's do this one. We got a geometric one here. So they gave us a sub 1. They have to give you a sub 1 if you're working with a recursive. They have to give you as many terms as involved in the equation. So they had to give me a sub 1 so I had a starting point. I knew what to plug in for a sub 2. Does that make sense? Because you're going to have to write these rules later. You're going to have to come up with them yourself. So a sub 2 then would be 1/2 the previous term, which is 32. So that would be 16. And then just keep going with that. A sub 3 would be 1/2 of 16, which is 8. I don't suppose we have to keep going, do we? Yes. Okay, I shall. 1/2 the previous term, which is 4, that would be 2. And a sub 6 is 1/2 the previous term, which is 1. Okay, it gets a little bit more complicated here, but you just plug in what you know. So, they gave us what here? A sub 0. It's okay. We can work with a sub 0. So, we're going to find a sub 1, which is going to equal 2 times the previous term plus n squared. So what am I going to use for n in that equation? Which term am I at right here? 1. So plus 1 squared. Make sense? And that equals 7 when you do the math. Then a sub 2 would be 2 times the previous term plus the current term number squared. Cool? All right, you do the next 2. You do a sub 3 and you do a sub 4 and see what you get. Did that go well? Yeah, no, maybe? Okay. Can't tell by your faces. All right, so hey, we have something else here. Notice they gave us the first two terms, and they did that because look what happens in the equation here. We have to take the term before and add it to the term 2 before. Make sense? So let's see what that looks like. This is back one term, and this is back two terms. So if we go now to, where would we start here? A sub what? 3, because we already have a sub 1 and we already have a sub 2. So we're going to start with a sub 3, which would be back one term. A sub 2 has a value of what? 5. And then I add to it back two terms, which would bring me back to a sub 1 with a value of 6. And I add that together, and that's 11. Cool? All right, a sub 4 then would be equal to the value of the previous term, which is what? 11, plus the value of a sub 2 previous terms, which would be a sub 2, which is what? 5. A sub 5 would be the value of the previous term, plus the value of 2 previous. Very good. So you can just look at this here once you get it going. And then we'll do a sub 6 and we'll be done. The value of the previous term, which is 27, plus the value of the one before, which is 16, and that equals 43. So that's kind of the first thing you'll be practicing. But you know, it gets better. Okay. So recursive equations, now we get to write the rules. We get to come up with the rules. Recursive equations for arithmetic and geometric sequences, which is what you have on here. Recursive, arithmetic, recursive, geometric. So it's on here. Same thing. A sub 1 is the first term for arithmetic, and then this is how you would write it. You have to find the what? First you have to decide what? Whether it's difference or whether it's a ratio. And then you just use those equations. So, first, find D or R. And then second, write the rule. Write the rule. Now, on the test, if you see the word recursive, that has to be your clue that you've got to come up with a function that involves the previous terms or the previous two terms. You've got to look for that word. Okay, you've got to be able to identify what you're being asked to do. So this is an important term here. All right, so first of all, we have this series right here. Let's decide whether it's geometric or ratio. Can you add or subtract anything to get to the next term? No. So probably it's geometric, right? So what is the ratio? Does anybody see it? If I do 40 divided by 100, I get 4 over 10, which reduces to what? You all see what I just did? Remember, you can come up with the ratio by taking this term and dividing it by the previous term. So 40 over 100 reduces to 2/5. If you did 16 divided by 40, you would get the same ratio. So that's what R is, okay? So now, I've got to write down the first term. I know I've got to write the first term. Always, 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 you have to include that in your answer if you're writing a recursive function. You have to tell the people what the first term is. And then we just plug it into here, plug R into here to get our function. So it's A sub n equals 2/5 times a n minus 1. And that's it. The direction said write a recursive rule for the sequence, and we did that. Now your answer would include both of these. I will mark you wrong if you do not. See how we're asking it to use the previous term? You have to give the previous term so people know where to start if somebody's using this function. Okay? All right, so this one here, what's happening here? Plus 20. So that means that D is 20, which means it's an arithmetic sequence. So part of your answer, you have to write the first term, because we're writing a recursive function here. And then we just write this function here with D as 20. So this all is part of your answer. It gets better, because sometimes it involves two terms, and you got to figure out what it is. So, for example here, let's look at number 7. Can you figure anything out going from one term to the next? I can't. Going from here to here maybe is plus 12. That doesn't work here. Dividing 8 by 10 is 8/10, but that's not the same as 18 divided by 8. So when that happens, the pattern has to involve two terms. So write down your first two terms. Maybe your first three, just to see if you can come up with something. Now, when this happens, look for a difference between the first two terms. Does it equal this? So what if I see I have a 10 and an 8 somehow, can I get to this somehow? So if I did this, and this is just playing with it, it's just playing with it. If I did this, I know that 18 equals 8 minus negative 10. So I'm saying that this term equals this term minus this term. Yes? So does 10 equal 18 minus 8? Right. Does negative 8 equal 10 minus 18? Mrs. Burgess, it does. Yeah, okay. So I'm saying that the third term is equal to the second term minus the first term. I'm going to translate that now into a general function. I'm going to say that means that my a sub n is equal to a sub n minus 1. See how we went 3, 2 here? And then minus a sub what? Right on. So my function involves two terms. So this is my answer, but I also have to include the first two terms as part of my answer. So we know where to begin. Make sense? All right, let's do another one. Okay, so I don't see any way to go from 1 to 6, 6 to 6, 6 to 36 with just using two of them. So that must mean that I got to figure out a way using more than two. So let's just write a list here. A sub 1 equals 1, a sub 2 equals 6, a sub 3 equals 6, a sub 4 equals 36. Maybe I don't need them all right down, but let's see if I can get from one to the other. Does anybody see it? Yeah. Does. 1 times 6 is 6. 6 times 6 is 36. So it's multiplication. So I notice this. If I substitute in the term numbers like this, a sub 1 times a sub 2 equals my third term. That helps me come up with a general function. I'm going to rewrite it like this because generally you put the output on the left side for these. So if I write this, a sub n, how many previous is this one? And this one here is it doesn't really matter, but I just did it like this, n minus 2 times a sub n minus 1. Multiplication, you could flip that if you wanted to. See how much fun you're going to have here? How many of these do you have to include? 1. 2. You have to include the first 2 in your answer. Okay, so we have not even talked about iteration yet, have we? It doesn't take very long. Iteration's not very hard. It's a fun word. Say it. Iteration. All right. Find the first 3 iterates of x sub 1, x sub 2, and x sub 3 of this function for an initial value of x sub 0 equals 1. All right. Well, this is going to be one of my first values. So x sub 0 equals, I got to plug in 1. So I'm going to take this value, plug it into my function, and find out what I get. Oh, should do that. What does that equal? 2. When I plug in 0 to my function, I get an output of 2. I take that output, and that becomes my f of x sub 1. So I take this 2, and now I plug that into the function. 5 times 2. It's really very similar to what we were doing on the other side. And then f sub x sub 2 equals 5 times 7 minus 3 equals 32. And then I got one more to do. I got f of x sub 3. I take that value, plug it into the function. 5 times 32 minus 3 equals 157. Okay, now, what is it asking me to do? Find the first 3 iterates of x sub 1, x sub 2, x sub 3. So that would be this one, and this one. So I would just write them down. That's your answer. That's not bad. Keep it straight. Okay, we have to do a story problem here. You got a calculator? Because I'm going to show you something nifty on the calculator. Go grab a calculator if you don't. Condition is estimated to be about 500, so that's my starting value right there. A sub 1 is 500. Each day, an additional 100 mosquitoes are hatched. Ugh. The population also declines by 85% every day from pesticides and other natural causes. If it declines by 85%, do I multiply by 0.85? What do I multiply by? 0.15. You still have 15% left, okay? 15% remains. Write a recursive rule for the number a sub n of mosquitoes at the start of the nth day. Find the number of mosquitoes after the 5th day. Describe what happens to the number of mosquitoes over time. Okay. So I know my R, I'm going to multiply by 0.15 every day, so it's a geometric. But I also have to remember that I got to add 100 each day in part of my rule. So it's really not that hard to come up with a rule. If you think about it, your output is going to be equal to 15% of your previous day, right? They're killed by pesticides and such. So 0.15, a sub n minus 1. But then, what happens? You got to add 100. That's your rule. It wasn't too bad if you just kind of think about it for a second. Now, my starting value, my a sub 1, day 1, was 500. That's where we started at when we started this experiment. So let's find the value of day sub 2. That would equal 0.15 times 500. I'm just going to give you the numbers, plus 100, which equals 175. Now, just hold off a second for you, those of you that are anxious. I'm going to show you how to do this quickly on the calculator. You ready? Write day sub 3 here, day sub 4, day sub 5, or just day 5. Just write day 3, day 4, day 5. And then on your calculator, this is what I want you to do. Enter your starting amount, just on a blank screen. You don't need a y equals or anything. Let's see if I can get this so you can see it. Enter 500. And then you're going to put in this equation right here. 0.15 times my answer. You all know how to do the answer thing? It's down on the bottom below above the negative sign. You see it? And then you do plus 100. This is my starting amount. Now, once I put this in like this, it's constantly going to take the previous answer. So if I push enter, look, I get 175, which is what we got here. That's day 2. Push again, day 3. Push again, 118.9375. Well, obviously we're going to be rounding, but I just wrote it down. 117. Don't erase it yet, though, because I want to keep going here. That's all we need to write down. But look what happens when we keep pushing. What's happening to our number? It's reaching what point? 117. Okay? So just like when we were looking at the graph of those infinite geometric series, it kind of balances out at 117 there. That's kind of what happens. So if you want directions here, enter 500, then put function using answer as x. Then push enter. Repeat enter. If that makes sense. Hopefully that makes sense.